Our next speaker today is Dr. Cronn, who is, I don't have my bios. She is a nurse practitioner by training who works at the Medical College of Wisconsin and leads their injury prevention. No, I'm going to let her introduce herself. I apologize so much. But Dr. Cronn is actually not a member of our EDIC committee, but she was a key member of our conference planning committee. So we thank you so much for your participation here. And you have a really interesting talk today on motor vehicle crashes and making a representative dummy. So thank you so much for presenting, and I'm sorry, I don't have your bio.
Good morning. Thanks, everyone. So to clarify that, I've been a fellow in injury prevention at our Comprehensive Injury Center over the past 2 years, and that's also at the Medical College of Wisconsin. Okay. I think we skipped it, but that's okay. Okay, so before I get started, I'll just do a little bit of level setting. When we're talking about, there we go. When we're talking about crash test dummies and vehicle safety, we'll be talking about differences in biological sex, okay? Acknowledging that there's a wide range of gender presentations, but for this particular project, we need to talk about biological sex. Okay. So the question here is, why does sex equity matter in vehicle safety research? So mainly it's because what's happening is not equitable. Women and men in similar crashes have different rates of injury, different risk of death, and just women are bearing an entirely different burden of injury and harm. So men crash more overall, but even with the greater number of crashes, the chances of harm are greater to women, and the chances of fatal or extreme injury harm are greater to women. So this accounts for things like vehicle choice. Men generally drive bigger cars, drive more miles overall, and have a little bit riskier driving behavior. So in similar crashes, we have kind of just a little graphic here that shows areas of the body that women have greater injuries, or we'll just move on from that because I need to talk about it a little bit more in a different way. Okay, so we've established that we have differences in injury patterns. We've established that women are carrying a disproportionate burden of crash injury. So with this disparity, we would assume then that our crash test dummies and our vehicle safety testing is aligned with the disparities in crash injury and fatalities. We'd be wrong about that, though. So to represent adults, so all adults are represented by our guy on the right. This is our male crash test dummy. He's a 50th percentile dummy. These percentiles were calculated about 60s, 70s, and it's been sustained throughout this time. So he's approximately 5'9", approximately 171 pounds. This is the dummy that is used for all crash testing in companies, in manufacturers, in post-market testing, and in government testing. So what we use for female is a 5th percentile dummy. So she is about 5 feet tall, sometimes 4'11", depending, and about 110 pounds. So I actually went to the crash lab and met her, and I am very differently sized than our female dummy. So in addition to that, she is just a scaled down version of the male dummy. So it does not account for differences in strength, distribution of mass, body composition, or structure. So because of this, our current vehicle safety standards do not account for different body types. So in the stages of vehicle testing that's performed by manufacturers, there are quite a few different stages of crash testing that happen. And in the stages that are performed by manufacturers, which is just like initial compliance testing, the female dummy is used in a variety of positions. However, in NHTSA testing, which is our government entity that covers highway and traffic safety, the female dummy is either a passenger or not present at all. So the significance of this is that NHTSA testing is what's available to the public. The vehicle company compliance testing remains private unless they choose to disclose it, which seems rare. So because of this, consumers can't really make informed decisions about vehicle safety. So we ask, how has there been such a gross oversight in such an obvious problem? So the answer to this is just our usual admixture of structural reinforcement of social injustice. So the initial era of this research was the 1950s, really taking off in the late 60s and early 70s. So this was a time when men were more likely to be driving vehicles, women as passengers. It was also very heavily male-dominated specialty with the biomed engineering research. So we also have this ongoing lack of representation, which we've spoken about earlier today, in engineering, medicine, and surgery. But also important is legislation and industry. So another piece of this is just that in many areas of science, including medicine, male is the default. Also, we have to question whether there's value assigned to plight of different types of bodies and different types of people being represented in this testing. There's also been a lack of recognition of impact. In a recent letter, a body in charge of research, who shall not be named, actually said, when being called upon to mandate female crash test dummy use, and not just the 5%er, because she's tiny, they said, well, injury and death is going down for everyone, so vehicle safety is improving for everyone, so that's good, so we're good. It didn't go over well. They received a lot of mail about it. And then there's just been an ability to ignore this, right? We've just kind of let this go for a long time. So fundamentally, safety equipment, as it's designed to be used, is only safe for some people. And this is equality, right? This is our vehicle safety just being applied to everyone, and it's causing harm. So our current fixes are not adequate. We do have some companies that are working on better representative crash test dummies, but they're lacking quite a bit of the information to do that. So there are a few companies that have added increased number of sensors in the pelvis, assuming that the pelvis is responsible for some of these differences. And there's also some dummies that have like fat pads strategically placed. So our solution here is that we have to strive for equity. Okay, so a very brief overview of a huge amount of information. This is throughout an analysis. All of the data here is an analysis of the National Trauma Data Bank, and it's also being reflected in some of the SIREN data, which is a crash injury research engineering network. So some of the things that we know are women are considered out-of-position drivers. What that means is our safety equipment is designed for the 50th percentile male, and anything that's wildly different from that is not going to fit in the equipment appropriately. So if you ask your patients, especially if they're particularly small or tall or heavy, They may tell you that they wear their seatbelt differently than perfectly, right? That's how all of this started, is seeing a lot of breast hematomas and hearing a lot of patients say, it chokes me, so I tuck it under my arm. So women are considered out-of-position drivers. Different anatomy, we know that exists. Generally speaking, different size. Women tend to sit closer to the steering wheel. The angle of their legs reaching pedals is different. Less muscle mass and strength in upper torso and neck. And interestingly, so the seats throw women forward more because lighter bodies do not create the same dynamic that is calculated in vehicle safety testing. So things we don't really know yet are what factors cause out of position, right? So if you took an informal poll of just ourselves, there's probably some people for whom, no matter how far you move the, whatever that thing is called, you know, this thing. I should probably know that. But no matter how far you move that down, it's not far enough, right? There are some people for whom it still like chokes your neck or whatever. Changes in your body during pregnancy cause a whole different seatbelt issue. Breasts, the fat distribution can really be an issue. So we don't know all the factors that cause out of position, except for one of the main factors, which is 50% of the population is often considered out of position. We need to fix the position, right? So we also know we have differences in anatomy. Do we know that those differences are responsible? So far, what we know for sure is big heads, little necks. That's kind of as far as we've gotten for true understanding of differences in anatomy contributing to these disparities. And so when we find those differences, which ones and what's the impact? We also don't really know how safety equipment interacts with female bodies in crashes, because we have a tiny little dummy and not a 50th percentile. We also don't have a dummy that is truly representative of the female body. It's a scaled down male dummy. We don't know yet what injury patterns differ between male and female occupants in crashes. So we know the likelihood of this type of injury is increased in women, but we don't necessarily know what the associated injury patterns are for men and women in similar crashes. And then we need to talk about what other body factors need consideration. So size is obviously a Venn diagram. There's extremes of size. Most of the extremes of small size are going to be on women's side. Most of the extremes of height are going to be on men's side, with quite a lot of overlap in between. Do we need to consider disability? Do we need to consider weight for height? These are all questions that we're trying to answer. Okay, so I've pulled a huge amount of data out of the NTDB, which is sometimes a challenging database. I've had some surprises, actually, so far, one of which was the specific injuries that we had greater numbers of. So overall, men have greater numbers of injury in most categories using anatomy as well as AIS to categorize. So we just started with a frequency analysis to see if there was any kind of trend in this huge data set that we pulled. And it turned out that men were overall greater numbers and greater proportions in many of the injuries, except for liver and pelvis, specifically AIS 2 through 5 and AIS 2 through 4 for pelvis. But the interesting piece and the surprise was the shock index. So shock index is a ratio of heart rate to systolic blood pressure. And we expect that your heart rate is lower than your systolic blood pressure. As you're crossing that threshold into greater than 1, you're possibly showing signs of shock. So despite the generally lower severity and fewer numbers of injuries in women in crashes, their shock index was higher consistently in bladder, jejunum, kidney, all liver, large intestine, and mesentery, AIS 2 and 4 pancreas, bunch of pelvis, and stomach injuries. The other piece is where, in the types of injuries where women were, where both parties were crossing into shock, women crossed that line at a lower severity of injury than men. So that was a little surprise, and there's a lot of work going on to dig that out. So the implications here of what we found so far are significant because obviously this is a problem that needs to be solved, and it's kind of ridiculous that it exists to begin with. But as we go through injuries and are able to associate and attribute and control for size, weight, height, weight for height, if the shock index continues to be a factor here and continues to demonstrate that women are crossing that line at a lower severity of injury than men, we have even more impetus to force some meaningful change. Okay. So next steps for this. There are a lot of next steps, I'll be honest. We need to add thorax and spine. We initially started just with abdomen and pelvis, having to do with some testing that was going on concurrently, but then it just kind of became such a large issue on its own, it has become independent from that project. So we need to add thorax and spine. We need to look at TBIs. We're going to have a little bit of difficulty, of course, with shock index with some of the spinal injuries, but we'll have to figure out how to manage that. We also need to stratify and look at how age is affecting this. It looks like the differences in shock index pattern are greater in younger patients. We need to isolate our combined injury patterns and see if there's any trend there. And we need to take a look at the sex differences once we have those combined injuries and shock index and see if that is still a valid concern. So after that comes the analysis of the role of equipment impact on injury patterns. So the Siren network, if anyone's familiar with that, does a huge amount of picking apart of the engineering factors of crashes. It's actually really interesting to hear them argue about whether this person's face hit the console or the steering wheel. But they get very specific about what pieces of the car cause what injuries. So once we have injury pattern data, we can actually compare that with some of the Siren database. Computer modeling. So this is an ongoing and kind of huge project. And actually, a very recent development just over the past few weeks is that NHTSA has asked this particular crash lab to identify new 50th percentiles. So that will be a start there. Finally, after all of this comes together, is we need to start figuring out what relevant design criteria will be then. So we have companies, like I said, that are making 50th percentile crash dummies. We have things that are in the works, but none of them are doing this based on actual injury patterns and what's relevant to their criteria. We can say, make a female dummy. If we don't know what parts of that are important to include, then we just have another dummy. So as always, there are barriers to change. One of them is going to be acceptance of not just the relevant design criteria, but the need for relevant design criteria. This is going to be a big paradigm change. As I said, one of the largest bodies in charge of how this all works has been somewhat resistant to hearing about how we need to move forward in this, but it seems like there is quite a bit of momentum going into this. So I think this paradigm change is on its way to happening. So another barrier is the actual manufacture of female dummies. I've come to learn that these are really complicated, not just mannequins with a couple things in them. So the manufacture, once you get to relevant design criteria, is going to be complicated. Another huge issue is legislation mandating the use of accurate, representative female dummies in all the layers of testing. So not just the compliance testing, but also in NHTSA testing, and also public availability of that data. And finally, one of the barriers to change is going to be industry adoption. When it comes to changing legislation in vehicle safety, it goes through multiple iterations, and part of that is legislation starting, then industry having the chance to respond to that, and then coming back to legislation. So very complicated, a lot of things involved there, and it will take a while to get this to happen. So this is a very long-term project, but just so we have a perspective on a different type of disparities research that affects our trauma patients. So thank you very much.